is about reading legacy code effectively. Just a little bit about myself. I'm a software developer. I have a YouTube channel. I've written a couple of books. I'm on social media. Do get in touch. That's my email address. So I'm starting from the view that reading code is actually hard. And software developers spend a lot of time reading code. And it's particularly difficult when you're in a large existing code base that you didn't write. And that is a situation that I often find myself in. And actually, when I see code reading doesn't really encompass actually what we're doing here. We're trying to make sense of where we are in this code base and orient ourselves in it. It's not like reading a novel where you start at the beginning and you kind of get through it. These code bases are so large you can't possibly read all of them. You have to orientate yourself and work out where to go. So when I'm presented with unfamiliar code base, I need to quickly understand enough context to know where to start and find a good place to make the changes that I need to make. So I'm going to put a small piece of code up on the screen here. And 20 lines of code. And you can read this. This is just an example. There is a bug in this code. And I don't know if you're aware of how you're reading it and how the eye is scanning through the lines of this to look for the bug. But this is actually a piece of code that was used in an eye tracking study that some researchers did to try and work out how people read code. And I find that they had some interesting results here. So on this side is the piece of code, and on the right is the result of the eye tracker. Which line are they looking at over time? And the researchers identified this behavior that people are not reading the code from top to bottom generally. The eye kind of scans. First you scan the headers, and then you quickly look at both the function bodies, and then you start homing in on where the bug is. I don't know if you spotted it, there's an off by 1 error. It should be I less than or equal to max, just in case you're wondering where the bug is. But they looked at this eye tracking study, and they realized that the people who were doing this scanning behavior of like the eye flipping through the code quickly first, found the bug in more cases more quickly. So that this code reading behavior of scanning is actually helping them to read the code. There was another study of code reading where they were also tracking eye movements. They didn't have such good graphs in their paper though. But they found the same thing. Experts read code less linearly than novices. They're not starting at the top and reading it linearly through. Experts are better able to focus on the relevant source code elements than novices. And one of the effective ways to improve skill acquisition is to cue visual attention of novices to the locations that experts attend to. So if you've got an expert and you can work out what they're doing and what it is they're paying attention to, perhaps novices can get a leg up and learn to do this more effectively, more quickly. And this is, as I mentioned, an important skill for software developers in many organizations. So it led me to start thinking about, well, actually, I think I'm fairly good at reading code. What is it that I actually do? And I came up with this little list of heuristics or guidelines or things that I do when I'm reading code, not necessarily in this order, but these are the ones I'm going to try and talk about today and see whether it could help anyone here to read code more effectively. So I'm going to start by doing a quick scan of some code, not 20 lines, a little bit more. And I want you to think about what is your eye looking at? What do you see in this piece of code? So this is the code. There, and I pressed the wrong button. I knew that would happen. Sorry, that's the next example. So back to the presentation. So what did you see when you were scanning through that code? Well, this was a code example called tennis 6, and just from scanning through that code, I can see there's a long method, and there are code paragraphs. I don't know if you could see that too. But so these are both code smells. A code smell is defined by Martin Fowler and Kent Beck in the book Refactoring. And he says, a code smell is a surface indication that usually corresponds to a deeper problem in the system. And I think this is really insightful. Code smells are easy to spot. These two were very visual. You can spot them just by scanning through the code, looking at it like it's a picture, and not actually reading the words. Not all code smells are visual like that, but these ones are. And as with any code smell, it's not necessarily a problem. You don't have to fix this, but it warrants further investigation and discussion potentially. So one of the genius of having a name for this, having a smell with a name, is that you can now go and discuss it with your colleagues or ask somebody, is this all right? Is it like this? Or is there a reason why it's like this? The other thing you can do once you have a name for something is you can look it up and you can find out things that you can do about it. So in the refactoring book, the smells all come in the index. You can look up what refactorings you should use to address them. So in the refactoring book, there are 24 named code smells, and one of them is long function or long method. It's pretty much the same thing. And this is a smell that I hopefully showed you. It's easy to spot just by scanning through the code without reading the words. And it might not indicate a problem, but it could do. Several smaller methods would often be a better choice than one long method. That would be easier to understand and reason about, and less likely to introduce bugs when you change it. The other code smell that I spotted was a code paragraph, and that's not one of the ones in Martin Fowler's book. This is one I've learned from other programmers. Paragraph of code, I've written up a description of it on the salmancoaching.org website. This also is pretty easy to spot from scanning, just visually. What I think my eyes are looking for is a section of code that kind of has white space either side of it, and usually it starts with a little comment describing what this section does. And usually what you want to do with that is, well, it doesn't necessarily mean that this is the best approach, but you could extract that piece as a method and name it after the comment that's at the start of it. So this scanning, spotting these code smells, suggests to me a quick win of being able to extract a method. And I think that was the next bit of the demo. Yeah, so this is the code paragraph that I've spotted. This part, that's this tie score section here. It starts with a little comment. The same word tie score is appearing lots of times. That's another visual clue. So I use the extract method, and it even suggests to me in my tool to call it gets high score. And I think that paragraph is better off as a little method. So that was an example of a quick win that you can do when you've got you've spotted a code paragraph. Try extracting it, and your tool hopefully will be able to do that. So okay, I've got another example where we can do some code scanning. And I've got to flip in the right direction. Yeah. Okay. So what are you seeing when I'm scanning through this code? Yeah? So you might have seen this code before. This is the Gilded Rose refactoring kata. It's a particularly horrible piece of code. It's just such fun to fix this code. Anyway, but hopefully you can see when I was just scanning through that, we got a long method, the same as in the last piece of code. But this time I also spotted a lot of deep nesting, those brackets kind of indenting the code deeply. But also that the IDE had some highlights for me. It had highlighted a couple of things that the IDE was suggesting it could fix for me, which gives me the quick win. Let's just accept what the IDE has suggested. And then also, if I can, maybe I could extract some methods. So that's the quick win that I was going to just show you. From here, if I just go and put the cursor on the first thing, it's highlighted it in yellow, the for loop there. And then I just ask it to do its thing. It suggests the preview of what it's going to do. It's going to basically upgrade this from old-fashioned Java to modern Java. And this looks much easier to read with a proper for each loop over the items. And it'll just fix that for me. The next thing it's highlighting is here we've got an integer minus the same integer. That is crazy. That's clearly 0. And it's just saying, look, I can do that for you. And I'm like, yeah, Yeah, fix that for me. That clearly should be 0. So this is very quick. With the IDE, you can just do it pretty safely. So that's the kind of quick wins that I'm looking for. When I spot the IDE highlights, I'm just going to fix them. Okay, so I've got another piece of code here for scanning practice. What do we see when we scan through this one? Just scrolling slowly. It's a bit more of this one. Yeah, so what do we see here? This was Tennis 4, also from the tennis refactoring kata. Well, there wasn't a long method. I don't know if you saw that. There were lots of small things. But there was one line of code that was really long and strange looking. And then other than that, just lots of small things. So this scanning has, just seeing it like a picture, I'm like, that long line of code, I need to work out what is that. So this is that long line of code. And when I read this in more detail, I can see there's lots of classes being constructed here, and they all seem to be passing to the constructor of the next one. And when I think about this a little bit, I realize, oh, this is a design pattern. I recognize this. This is chain of responsibility. So I homed in on this one, and I can see, and these are the classes involved in the chain. The next thing I'm going to do when I've got lots of small things is just fold up the code. So that's the thing my IDE can do for me as well. Just it's called collapse all. It will just take all of the blocks and just kind of collapse them into these little expandable chunks. And then suddenly I can see all the classes I've got here, and I can see the interface that most of them implement. And then I can see, oh yeah, this is my chain of responsibility, and result provider is the interface for the chain elements. So your IDE folding the code can help you to get an overview of a larger piece of code. And if there are a lot of small things, maybe you can see some commonality between them when you've done that. And quickly understand the structure. Look for patterns. There's also an IDE feature that I use sometimes, which is structure view, which is kind of similar. So here is the structure view of the same piece of code. And the IDE is a bit like collapse all. It kind of gives you a summary of all the things that are there, color-coded, with a little bit of icons to help you to work out what is here. And then you can clearly see that these classes have the same data members, the same structure, the same methods. And then maybe you only need to read one of them. So that sometimes the structure view helps, sometimes it's just easier to collapse all the code. So this collapsing all, I also use this when I've got a long method. So this is back on the gilded rose. The update quality method was that long method we were looking at before. So if you just collapse the code, the top level structure is not very interesting. You can see, well, it's all inside that long method. That's where all the stuff is. But if I just unfold it 2 steps, suddenly I get a lot more information, actually. Suddenly I can see that the entire update quality method is a for loop. There's nothing else except for one big for loop, which immediately suggests to me that I could extract the body of a for loop as a method. But if I go one level in further, I can see that the for loop contains 3 if statements. And these 3 if statements are a bit funny looking, because these ones are both negative, if not something. And then this one's in the positive. But that kind of gives me a clue that when I see an if statement with a not statement at the start, I'm just like, well, what's going on here? That's something I might want to investigate. So the code folding has helped me to see the top level structure of the big long method and suggest maybe some refactorings. And then the next thing that I might want to do is scratch refactoring. So this is a technique from Michael Feather's book, Working Effectively with Legacy Code. He suggests one of the best techniques for learning about code is refactoring. And learning about code is what you're doing when you're reading code. And it turns out that you understand the code better if you try and change it. The point about a scratch refactoring, though, is that you throw away your changes. You're doing the refactoring purely to learn about the code. You're going to restructure it, you're going to move things around, you're going to learn more about how the code is put together, and get some feedback from whether your changes still compile, whether if there are any tests, whether they still pass. And you use that to inform what you know about the code. So I've got a bit of code that I'm going to scratch refactor. So this is Gilded Rose. I spotted these not, if not something here. I'm like, well, what if I just flip those? My IDE can flip the sense of the if statement very easily. It doesn't look much better, but now I can see I've got a compound if here with an or in the middle. What if I split that? Split it into two if statements? Yeah, I'm not sure this looks very much better. It seems to have just got longer. I've got some IDE quick fixes. I'll see what happens if I fix those. Yeah, it's still looking a bit strange. Oh, here's that other one with the not. What happens if I flip that one, invert it? And that's interesting. So now I get an empty if clause and just an else clause. There's something strange with Sulphurus. There's something odd going on here. There's an if that is my IDE is offering to do something. So I'll take the suggestion. It moves it into the next if statement, but it's still got this thing with it. There's an empty, the positive case is empty. So at this point, I'm looking at this this long conditional. It just got longer. It got more confusing. I haven't actually, I don't want to keep these changes. I don't think I've improved the code. And one of the measures of a good refactoring is you've improved the code or you know a new direction that is going to improve the code. So I'm going to throw this away, but I did actually learn something. There's something weird about Sulphurus. And if you continue, you realize, yes, there is something very odd about Sulphurus. It's different from the other ones. So maybe this scratch refactoring has helped me to be alert to that. But I'm going to, at that point, throw away my changes. So that's the point with a scratch refactoring, is that you revert. It's important that you take the learnings and you just try something else. Throw away your changes. There is definitely a pitfall with this, that you're doing scratch refactoring just to learn about the code, and you start to like the design you come up with, and you start to think that actually it's okay, maybe I'll keep this. But you have to be very bit careful of that, because sometimes when you're scratch refactoring, you might also not be taking enough care to make sure your changes are refactorings. Sometimes you're kind of going a bit wild just to see what happens. So the safest thing when you're doing this is to throw away your changes, do it again in a more disciplined way, in smaller steps, with paying more attention to feedback. So then the next strategy I wanted to mention was communicate. Put what you've learnt into the code and make it more readable for the next person. So part of this basically is, as you learn what the code does, put that information into the code by renaming things in the code. So we saw that before with I was reading the code, and a quick win was to extract a paragraph, name it as a method. I've now put that name into the code, and the next person won't have to scan for that paragraph. It's a named element that they can more easily find. So what I'm going to show a little demo now of. I've got a bit of code here which I've been looking at. It looks a bit impenetrable at first. It's a long method, lots of stuff going on, and I found this variable called curly braces. And I'm like, curly braces is entirely meaningless in this domain. It means nothing to me. It's actually a very bad name. So I think, well, let's just be honest about that. This is absolutely nonsense. So I'm just going to rename it applesauce. So applesauce is the name you use when you don't know what to name something. It's like a placeholder. This says this is obviously nonsense. So I think this is actually, in this context, a better name than curly braces, because it screams, this is a bad name, which curly braces was, there are some occasions where that might be a good name, but this wasn't one of them. So the first thing I'm putting into the code my understanding that this is a bad name. And it's a kind of a marker now to anyone reading this code that we could improve this. So then maybe I'll go on a bit and learn a bit more about the code. And I'm looking at where applesauce gets used. And I think, here I'm comparing this to the string nemesis. Now, nemesis is something that is meaningful in this domain. It's an attribute of character. So I now know enough to rename applesauce to something better. So I'm going to rename this element again, but this time I'm going to call it maybe Nemesis or something. Because I'm not, this is just one place I'm comparing it. It might not always be Nemesis, it could be something else, but I'm putting into the code my understanding of what this is so far. This is Nemesis or something. And then I'm looking, and there's other places where it refers to curly braces, and maybe I should rename them as well. A local name without curly braces. Well, that's basically, now I know that curly braces is actually Nemesis or something. I can rename that local name without Nemesis or something. And gradually the domain language about what I've learned about the code is going into the code and is going to be there for the next person. So that's enough of that for the moment. This process that I'm describing is from Arlo Bache. It's called naming as a process. And he's written this up as a 4-step process, or the previous iteration he had 7 steps. But it's all about, as you read the code, putting your understanding into the code, improving the names, improving the structure as well as you get to the later stages. And that means that the code gets more readable over time, and the domain language starts to appear in your structure view, and when you're navigating through the code base, you start to see words that are relevant to your domain. So there's more to it, but go and read the article. So this is just to summarize what I've been talking about today. When it comes to reading code effectively, I think it helps to use some of these heuristics that I use when I'm reading code. Scanning, powerful, just don't read the words, just look at the shape of it and learn to recognize patterns. Take the advice of the IDE with the quick wins, but also if you see a very obvious code smell that you can very obviously fix safely, fix it, extract that method. Sometimes it's a good idea just to allocate some time to just try stuff and see what happens and learn about the structure of the code. And don't worry too much about whether what you're doing is safe, but don't forget to throw it away if you're doing that. And then when you are reading code and you have an insight and you realize what something is, rename it. Put the information you've learned into the code. So that's my advice for reading legacy code. Thank you.